Section 1.2 is continuing where we're going to analyze graphs of functions and relations and focus on domain and range. So most of this is just complete review, but I want us to really have a strong understanding of how we write domain and range. So let's look at number 1. It says state the domain and range and write it in interval notation. So that's where we're going to use our parentheses and brackets, maybe infinity symbols and so forth. And then we're going to determine whether it's a function. So for the first one, we're looking at our x values for domain, right? So we look at from left to right. So what's the furthest we go to the left? In this case, there's no arrow, right? It is stopping. And so it's a line segment that we have. So the furthest I go to the left is right here. And that's at the x value of -3. Now I see that that's a closed circle, so it's included. So I'm going to start at -3, use brackets to show that it's included. And then as we go to the right, there aren't any gaps along the way, but it doesn't continue on. It stops at 4. So my domain is from 3 to 4, and they're both included, so I have a bracket. Now let's do our range. So for range, it's our y value. So that's looking up and down. So what's the lowest I go? Well, the lowest I go is at that ordered pair, 3, -1. So that y value is -1. Then that line is increasing. It's going up. There's no holes or gaps along the way. And the highest that line segment goes is to +2. So there's my domain and range. Now to determine if it's a function, remember, use that vertical line test. Think about if I pass a vertical line through, does it hit just once at every spot? And yes, it does. So this is a function. Okay. Let's do number 2 together. So for number 2, our domain, we're looking at left to right, right? My x value. So as I go to the left, we see this V shape. Of course, it's going up, but it's also bearing off to the left. And there's an arrow. So we're going to keep on going forever and ever and ever, not only up, but towards the left. So that means our x values are going to go all the way to -infinity. Remember, with infinity symbols, we always have a parenthesis because infinity is not an actual tangible number that we can get our hands on, so we don't actually include it. All right, now we continue on and we look at as we go to the right. Are there any gaps along the way on this V? Nope. And as we go to the right, again, not only is it going up, but it's going to go to the right forever. So our domain is going to be all real numbers from -infinity to +infinity. Now let's talk about the range. So for range, it's our y values. So I look up and down. So I always start with my lowest value. So what's the lowest that this graph is going? The lowest it hits is 0, and it's included. So I'll include it with a bracket. And then we can see that V is going up, and that arrow is telling us we're going up forever. So my range will be from 0 to infinity. Now, is this a function? Again, pass a vertical line through, and yes, it is a function. I'm going to do one more with you, which is number 5, and then I'm going to have you go back to do 3 and 4. So for number 5, our domain, we've seen ones like this before, so let's see if you can do it. We're going to look from left to right. So as I look to the left, I have this arrow here of going on forever. So that means that -infinity will be where I start. Now, as I go towards the right, does this graph continue to the right forever? Well, there's a hiccup along the way, right? There is a hiccup right here, and I'll just put a little dotted line at 3. The graphs both approach that, but never touch it. So therefore, my domain isn't going to be from -infinity all the way on forever. We're going to have to stop at 3. And we never hit it, so it's a parenthesis. Now, there's still more to the graph, right? There's this upper right piece. So what that means is we have our union symbol, and we pick back up at 3, and we can see all those x values are plotted, right? 4, 5, 6, etc. And that arrow is saying go on and on to +infinity. So in this problem, just about everything is plotted for x's except for where I drew in that dotted line, which is at 3. Now let's talk about the range. So my range, we start lowest to highest. So as I look down, there's an arrow saying have that curve go down forever. So again, our range will be from negative infinity. And does that curve go up forever? Well, that left-hand curve, it goes up, but it's approaching what I'm going to draw in now at 0. So it never crosses through that x-axis. So our range is from negative infinity to 0, but then we pick back up and we're from 0 to positive infinity with the graph above the x-axis. So that's how we write it in interval notation. Remember, with set notation, we would simply just say for domain, x can't equal 3, and for range, y can't equal 0. Pretty basic there. But we want to get used to this interval notation because that's how you'll see it in higher level maths. All right, now is this a function? Yes, it is. All right, you guys try number 3 and 4, practicing domain and range in that interval notation and determining whether it's a function or not. Now let's review finding domain, not range, just domain when we're given an equation. Remember, what are the 2 biggies that we look for? That could be a red flag. Watch for fractions and radicals. Otherwise, your domain is going to be good to go to be all real numbers. So if we look at number 6, that's just a line, right? Y equals mx plus b. So it's a line, and if you even want to think about the picture of it, right? Negative x minus 3 is going to be something like that. And think about my domain. My x's to the left will go on forever. My x's to the right will go on forever. So this domain is simply all reals. And that's what most linear equations will be because, again, there's no fractions or radicals. There's no constraints there. It's okay to plug in whatever we'd like. Number 7, let's review number 7. This one has a radical. So remember, for radicals, we take what's inside the symbol and make it be greater than or equal to 0. What's inside must be a positive number or a 0. So once I do so, I solve that. And I know that my domain has to be all the values greater than or equal to negative 2. Well, how do I write that in interval notation? If I'm greater than or equal to negative 2, it means I'm going to start at negative 2 and include it because it's greater than or equal to. And then if I'm greater than, it's going to go everything to positive infinity. You try 8. Remember, for fractions, we can't have our denominator equal 0. So figure out what would make that 0 and then do your best to write that in interval notation. I'll give you a big hint. You're going to use that union symbol twice. All right, and the last ones we're going to look at are new problems, but they're pretty basic. So it's just evaluating functions, but with a graph. So in the past, on number 9, when I saw something like this of f of 2, it was saying take 2 and plug it in for y. In this case, we're just going to look at where is the graph when it's x equals 2, right? F of 2 is saying, really, what is the value of the function when x equals 2. That's what it's saying. So we go to where x equals 2, 1, 2, right here, and I go up to where I meet my graph. And it looks like right here. So where is that value? It's at 12. So therefore, f of 2 equals 12. You may have to approximate here and there, and that's okay. Give your best approximation. Okay? So you try doing 10, 11, and 12. These are your x values, and find the corresponding y values based upon where it meets the graph.